Hi. So today we are going to cover the very basics of Matplotlib. Um, so what I want to do at the start is just point to this really good tutorial which is there on Matplotlib's official website. It's called the PyPlot tutorial. What I've done for today's video is that I've taken content from that tutorial. I've implemented it on my Python notebook, and I'm just going to walk you through it. So let's import NumPy as NP, and this will just help us generate data. Next, let's import the Matplotlib library. And the way it is done is you say import matplotlib.pyplot, and the convention is that you import it as PLT. So that's the standard that you use. You can use other names also, but mostly everybody in the industry would use it as PLT. Now, here you notice a slightly different looking line. And this line, what this line does is that it tells the system to display any plots in line that is inside the Python notebook. So if you don't put this line, you might not be able to see your graphs in line inside your Python notebook as you're coding. Now, as we start off with Matplotlib, a very important thing to know about Matplotlib is to understand how it works. So, what Matplotlib does is that think of it this way. So, the canvas on which you plot your graph is called axis. That is AXES, axis in Matplotlib. So whenever you make a chart or a graph, this kind of a canvas which you see on your screen right now gets generated, and this essentially, this square area is your play space where whatever you do gets implemented here. And within this axis, you build whatever you build in the form of a figure, right? So Matplotlib has these two functions, which is the GCA function, which if you call this function, it will return the current axis to you, and the GCF function, and if you call this function, what it will do is it will return the current figure for you. Uh, an important thing to note here is that this axis is not the same as x-axis or y-axis. So that is usually x-axis, spelled like AXIS, but this is axis, right? And it does not in any way relate to axis. So what axis in this sense, in the sense of Matplotlib, means is a canvas space, if you might want to call it that. Now, what happens is when you call this function plt.plot. Now, the moment you call this function, it'll create a new space for you in the form of an axis like this, like the one you see here, and you build on top of that. So once you call this command, any command that you pass after this, so you say plt something else, all of that kind of piles up on top of this to make your eventual visualization. And if you want to make another visualization, then you have to start a new Matplotlib visualization by running this command again, so that it gives you a new set of axes, that is a new canvas, and on top of that it initializes a new figure, and then after that whatever commands you give will be built on top of that axis into that figure, into a new visualization. So I think this concept is really important to understand, and I'll talk more about this as we progress further. So for example, here what we are doing is we are calling plt.plot, and we are passing some data into it. Now what will happen is once you call plt.plot, it will allocate some axis like this to you, and on top of that it will build a figure, and that figure you can see as a straight line. Now note that here you just passed a list of numbers. So by default, what Matplot does is that if you just pass one list and not two lists, if you just pass one list, it will allocate that list to y. So here what has happened is that these numbers 1, 2, 3, 4, these four data pointers have gotten mapped to the y-axis. And the corresponding values of x for this will be taken as 0, 1, 2, and 3. And that is why if you observe the figure closely, on the y-axis it starts from 1, goes till 4, which is consistent with the data we passed to it. But on the x-axis, which we did not originally give it, it starts from 0 and goes up to 3, because this is something that Matplotlib has generated on its own. So once you do this, what will happen is that you'll get this straight line. And as I said previously, any command that you pass after this will be built on top of this, and it'll keep on adding more features, if you might want to call them features, on top of this visualization. So here you're saying plt.ylabel. So you want to put a y label on this plot. And so because you're calling this right after this definition, and this definition has already defined an axis and a figure that you're working on now, so this y label will automatically get appended to that. So you see this figure, so y label will automatically get associated with this figure. And when you call x label, it will get automatically associated with this figure again. Now let's move ahead. For this example, we just passed one set of data in the form of a list. Now let's see what happens when we pass two set of data into the same command. So we are giving it two lists, 1 to 4 on the y-axis and then 1 to 4 on the x-axis. So now because we are explicitly giving the data to be plotted on the x-axis, that is why it, unlike the previous chart, it is not randomly starting from 0 or by default starting from 0. It is taking the data which you gave it, which is from 1 to 4. Right, now let's try and decorate our visualization a little bit. So this is the exact same code that we used previously. Now there is a parameter which is called the line width parameter, and you can use this parameter to control the width of your visualization or the line that you're plotting. If you change it, your line changes. It becomes thicker or thinner depending on what value you pass here in line width. So this is one control that you have, using which you can control the thickness of the line that you're plotting. Now let's play with this a little more. Let's try to change the color of the line. So if I want to change the color of the line, what I can do very easily is pass the color variable. I can say b and a dash, which means that the line needs to be blue in color. And I might have to paste this here, though I made a mistake. And so our line is now blue in color. I can make it a dashed line by giving, instead of giving it one dash, if I give two dashes, it will become a dashed line. And I can change the color by, instead of B, if I write G, it will give me a green line. If I write R, it will give me a red line. So this is how you can control the color and the type of the line. Further, if you do not want a line, but you just want to point out the data pointers on your graph, what you can do is, instead of a dash, you can give it this symbol, which essentially means plot a triangle for me. If you don't want a triangle and you want a circle instead, you can do that as well. You can say RO and it will essentially give you a circle. If you want green triangles, you guessed it right, it's going to be G and the symbol. Okay, so let's move on and see what else we can do with Matplotlib. Now, suppose your data is in this format. So you have 1, 2, 3, 6, and then 1, 2, 3, and 10, right? And that is how you want to scale the x-axis and the y-axis. So what you do is you follow a format like this. You make a list which essentially in sequence gives the x minimum, the x maximum, that is the minimum of the x-axis you want, maximum of the x-axis you want, minimum of the y-axis you want, and maximum of the y-axis you want, and you just pass it into a function called axis. So you pass a list into this function called axis, and it changes the axis for you. So now you see the x-axis as we wanted it to be goes from 1 to 6, and the y-axis goes from 1 to 10 as we had anticipated. Let's see what happens if we neglect this. If we neglect this, it still gives you the same output, but you see the number of it is skipping by 2 instead of going there step by step. So you can play around with your axis like this by specifying where it needs to stop till what point it needs to go. Now, an important thing to note here is whatever data you pass in to your Matplotlib functions, it automatically in the backend gets converted to NumPy arrays. So that is something that will not affect you much because there's a layer of abstraction, and all of this happens in the backend, and you don't need to bother about it. But just as a fun fact, Matplotlib processes everything in the form of NumPy arrays. Okay, so let's see. Let's try and use all the different formats of playing around with the type of the line that we discussed in the past into one single chart. So what I'm doing here is that I'm using NumPy to generate numbers from 0 to 5 with a gap of 0.2. So this is what arange does for you. It generates numbers from 0 to 5, from a lower limit to a higher limit with whatever increment you give it. So for those of you who are not very familiar with NumPy, I think this is something it's very frequently used, and you're storing it in a variable t. And then inside plot, you're just passing t twice. That means on the x-axis also there's t, on the y-axis also there's t, and so it's going to be a straight line at 45 degrees angle. And let's see if that happens. We'll just take out the rest of the code and try and run the graph. And that is exactly what is happening. So x is exactly same as y, and so there's a straight line r, red in color, and double dash, so it's double dashed. On the same graph, let's try to plot other things. So the next line that I want to plot is t on the x-axis and t raised to power 2 t square on the y-axis, and this the argument which I'm passing for it is bs, right? So I want b as in blue and s as in squares. So you get a curved line which essentially follows the y is equal to x square function in the form of blue squares. And then the third one is t on the x-axis and t cube on the y-axis, and how we are styling it is green triangles, right? So you get green triangles here. Let's try to do one more interesting thing. Let's see if we can break them out and pass them one after the other. Let's see if it works. And it works. So the exact same thing happened, which was happening previously, and this also goes back to the previous point about first defining an axis, a figure, and then sequentially building on top of it. So here, what we are doing exactly the same thing. With the first command, we defined a new axis, a new canvas, if you might want to call it that. And on top of that, sequentially, we started adding things. And after that, whatever you add is just going to get added to the same figure, to the same axis. And plt.show is something that you write just to tell Matplotlib to display the graph. That's it. That's the entire function of plt.show for now. What if you don't write plt.show, right? So if you don't write plt.show, what happens is when you run the last command, you get these three funny looking lines before your visualization. Now they do no harm and they don't really impact your visualization much, but it doesn't look really nice and it's not much of use for you, right? So there's what you can do is either you can write plt.show and these three lines will not be shown, or you can write a semicolon after this, which is very unusual for Python code. But what this does is that helps suppress any unwanted output from this line. So if you write a semicolon after this, you'll see that the three lines have vanished. But in general, it's a good practice to always write plt.show. Cool. So the next thing that what we want to do is talk about the idea of figure size, right? So if you look at this figure, it's certainly smaller than this figure here, right? But it's essentially the same graph, the same code, everything is the same. So how exactly do you change the figure size in Matplotlib? Well, it's pretty straightforward. What you do is you just use the function plt.figure, and within that you pass the argument figure size, and here you can define what the figure size needs to be. So for example, if you want to make it bigger, make it look more broader, you can increase this. If you want to make it look more taller, you can increase this, and you can play around with the size of the figure. So you can optimize it as in how you want to show your graph. So this plt.figure and then figure size is the argument, is something important that you will use a lot of times. Okay, so let's come to this important point of how do you use a data set. So for example, if you have a pandas data set or if you have a dictionary, how do you use that within Matplotlib? So here what we're doing is it's pretty straightforward. It might look a little intimidating at first if you're not used to data sets or dictionaries, but it's pretty straightforward. So here we are saying that A is defined as np.a range 50. That is, A has all the numbers from 0 to 50. And then C is again defined as np range 50. That means C has all the numbers from 0 to 50 in sequence. And then D is also defined as npa range 50, which means D has all the numbers from 0 to 50. You can just ignore this divided by 40 for now. I'll just remove it for now. Now what we're going to do is we're going to use X, that is numbers from 0 to 50, as my X axis. I'm going to use B as my Y axis. I'm just going to say that, hey, whatever the value of A is, just, add 10 to it. So take the value of A, add 10 to it, and then multiply it by a random number, which we are generating through this function, which is np.random.rand. So just generate a random number, and just multiply this by that. So we're just trying to create a random set of values for B using the values of A as input, just to get a random set of data for a y-axis. So just to repeat, so A is the set of x values. Then we have b, which is a random set of values derived using the values of a. And then we have defined two more things, which is c, which is values from 0 to 50, and then d, which is again values from 0 to 50. So what we're doing here now is that we are plotting a scatter plot, and that is what plt.scatter is for. We are passing a as the x-axis, we are passing b as the y-axis, we are passing c, this value, the 50 values that we defined here, into a parameter called c. I'll talk about this. We're passing d into a parameter called s, and then we're defining for Matplotlib that hey, a, b, c, and d that we are referring to are actually defined inside this dictionary called data use. So we're telling it, hey, data is equal to data use. That means you can take the data from data used, and then we just plot it. And what's happening is, on the x-axis you get a, on the y-axis you get b. We get a scatter plot, which is for every data pointer, for every value pair a comma b, we are getting a point here. And now let me talk about what the c and s is doing. So c is defining a random color for each of these data points. So you see these are all colored differently, and that is what c is doing. So c helps you define color, and here we are feeding it 50 values for the 50 points, and so every point has a different value. And s defines the size of the data point, and so to s also we are giving 50 values for the 50 data points. And if you observe very closely, the values on the top right side are a little bigger than the values on the top on the bottom left side, and that is because as we went on plotting, this kept on increasing. So it went from 0, 1, 2, 3, and all the way to 50. So the points to the right are slightly bigger. Then you can control the size here. Remember, there was a divided by 40 here, and I had removed it earlier, right? So this is the figure which I've plotted by using divided by 40. Now what if I make it 20, right? So I'm just increasing the size here, right? So it becomes bigger. What if I just remove it, right? So it becomes huge, right? So you can essentially control what the size of each dot needs to be using the s parameter. But you have to keep in mind one thing, that is, you will need to pass in as many values of s as there are data points. So that is why we're passing 50 values here, right? Cool. There's another interesting parameter here which we'll just plug into the same plot that we made, and that is the alpha parameter. What the alpha parameter does is that it helps you make your points transparent, so that if there's a lot of data and you don't want, and you anticipate there'll be some overlaps, you can make them look transparent. So here I'm saying alpha is 0.05. Alpha is 0.5, that means there is 50% transparency. If I make it 0.8, the transparency will reduce and they'll become more opaque. If I make it 0.1, they'll be really very transparent, right? So you can just play around with this and make it as transparent or as less transparent as you want. Okay, so just moving on to the last concept here for this video, and that is if you want to plot multiple plots and present them as a grid. So for example, here we are plotting 3 plots in a grid which has 1 row and 3 columns. So how do you do that? So it's pretty straightforward. The way to do it is there's a functionality which is called subplot. And how to use subplot? So you see there are these 3 digits within subplot, and what these 3 digits tell Matplotlib is how many rows, columns do you want, and what should be the position of the plot that you're dealing with right now. So what I'm doing is I've passed in the parameter as 131. So I'm telling it, hey, I want 1 row, 3 columns, and the plot that I'm talking about right now needs to be in the first position. For the second one, I'm saying, hey, there needs to be one row, which is one row, three columns, and this second plot needs to be in the second position. And for the third one, I say, hey, there needs to be one row and three columns, and this needs to be at the third position. So this one appears at the third position for me. And just to kind of emphasize, anything that you write before the next subplot will get associated with the previous subplot. So any statements that I add here, these statements are going to get associated with this subplot and not this subplot, right? So for example, if I change the x level here, I say, hey, this is changed, right? And I run it. Now because this was under this subplot and before this subplot, so it's going to just affect the first subplot that we have. That's it. It's a very simple concept. So the way you define it is in the form of three numbers. The first number is rows, the second number is column, and the third number is the position of that subplot within that grid. You can also put a comma here if you want, and it will still work the same. So it's up to you which format you want to use. A lot of people don't put commas, so this is something that you'll see very frequently. And then again, the last thing again is a demonstration on subplots. And so what we're doing here is we have a 2 1 1 grid. Now how to interpret this? So there'll be two rows, there'll be one column, and then we're talking about the first subplot, right? So there are two rows, there is just one column, and then subplot 1 and subplot 2. So 2 1 1 and 2 1 2, and then you can just plot whatever you want to plot here. You can play around with the colors, the types of lines and so on. So for example, if you want to change this to green, you can do that, it will change to green. If you want to change the color, you can do that, it will change the color, and so on. So thank you so much all of you for watching this video with me here, and if you have any questions, any comments, just feel free to leave them in the comment section below, and I'll be more than happy to answer them for you. Thank you so much.